Hi guys, it's Miss Nichols, and today I'm going to be talking about net force and doing some practice problems so you can see it before our quiz. Um, you can see I have some problems, some examples already in front of me. But before we dive into that, I just want to say that I didn't make these pictures or images and anything like that. I actually got them from the Physics Classroom, which is a website I highly, highly, highly recommend for if you ever want to, read a little bit more about what we're studying in class, or if you're really interested in it, maybe you're really interested in, I don't know, reflection or sound waves. If you're a giant dork like I am and you want to read the stuff in your spare time. They also have a lot of practice problems. They do check your understandings and the answers are already there. So that's also good practice before a quiz or a test in my class. Just a shout out to them. All right, let's go ahead and get into our problems. So I want to, what do I want to do? I want to do a screen sketch. Is it going to work? My pen doesn't always work. Screen sketch. Okay, so what is net force? Net, just like if you are thinking of net income or anything like that, it just means everything added together, all the total. So I want a pen. And I want it not white. So net is just total, everything added up. So for example, maybe I get my paycheck from Springdale Public Schools and they've given me, I don't know, $1,000. Okay. But then I also pay taxes like a good citizen. So my taxes are going to take out, say, $300. So they take $300 out of my paycheck. So even though my gross income was $1,000, my net income, what's everything added together once they take all my taxes out, is only going to be $700. Great. So now we just need to apply that thought to forces. If you look at this first guy right here, you'll see that I have force of tension, force of tension pulling up on a box, and force of gravity pulling down on a box. And I need to figure out what the net force is. So I just need to think about, okay, I have forces going in two different directions. So just like we've subtracted vectors in the past, I need to subtract these two force vectors. Okay, so thinking about that, I would have 1200 F net is going to equal my force of tension minus my force of gravity, or plus it, and that's going to equal my 1200 newtons minus, because it's going down, 800 newtons. So my F net is going to be 400 newtons up. Have to give it a direction, up. Let's just look at the second one. Great. Still just two vectors and they're on the same direction here, up and down, same plane. So I'll just say for this one, so it makes it easier to see, F net is force of the air plus force of gravity, which is going to equal 600 newtons minus, because it's going down, 800 newtons. So it's going to be left with F net equals negative 200 newtons, or 200 newtons down. You can put either one. Let's look at this last one. Now I have two different directions. So I need to think about my F net along the y-axis and my F net along the x-axis. So vertical plane, that's my y-axis. Horizontal plane, that's my x-axis. So I have my F normal plus my force of gravity. But when I add those together, I'm going to end up with 50 minus 50. So in this case, my F net in the y direction is 0 newtons. That means it's balanced. Woohoo! Constant velocity. or no velocity. Constant velocity, yay, not changing. Let's look at the x direction. In this case, I only have one force in the x direction. So that's going to be my net force. So my F net in the x direction is equal to force of friction, which is going to be negative 20 newtons, or 20 newtons to the right. Fantastic. I'll go through a couple more examples. I have some more, just so you can keep seeing, maybe you can see the pattern. Okay, so let's scroll down. Got 4 new situations here. And I want to do a screen sketch. These two, situations C and D, only have one direction. And I can quickly see for situation C, F net is going to equal 0. Because net is going to be equal to the norm plus the gravity. So it's going to be 20 minus 20 equals 0. Balanced. Balanced. Okay. Constant velocity. Let's look at situation D. My F net is going to equal my F of air plus my F of gravity, and that's going to be 40 newtons minus 25 newtons. And that's going to leave me with, what's 40 minus 25? I hate doing math in my head. Well, it's unbalanced. Unbalanced. Okay. Yay. Let's do situation A and call it a night. The reason I want to talk about situation A is because, again, we have 2 directions, but in this case, I have 2 directions and I have 2 vectors in both of those directions. So for situation A, F net of y, we're going to have our F normal, our force normal, plus our force of gravity. And that's going to be 3 newtons minus 3 newtons, which is 0. I'm also going to have my F net in the x direction, which is force of friction plus the force of application, or force of the push, as we've been calling it in class. So it's like someone's pushing against a box and there's friction pulling backwards. So force of app, that's fine. So force of friction is backwards, so that's negative 5 newtons plus our force applied, which is 5 newtons, which means, again, our F net in the x direction is going to be 0 newtons. I hope these examples have been helpful to you. If not, please be sure to grab me in class and ask me lots and lots of questions, because it's the only way we can learn. All right, have a good night, guys. Bye-bye.